Hello, my name is Frederick and I'm going to talk about the atom magnesium. Magnesium was first discovered in 1618 when a farmer from England couldn't get his cows to drink the water from his well. It turned out to be because the water contained hydrated magnesium sulfate. Even though it was discovered in 1618, the first time someone made a metal out of it was in the 1808 by the French scientist Antoine Brisy. But it was only a very tiny but pure magnesium metal. Magnesium is a chemical element, or normally just referred to as an atom, on the periodic table, and is the third most used metal. Magnesium is a gray, whitish metal with a density 2/3 of aluminum. Magnesium is a solid at room temperature, and it has a melting point of 649.85 degrees Celsius, so that's where the magnesium goes in liquid form, and it has a boiling point of 1089.85 degrees Celsius, and that's where magnesium starts to go in gas form. On the periodic table, magnesium is in the second group, which means that it has 2 electrons in its outer shell. It is also in the third row, which means that it has 3 shells. Magnesium has the atomic number of 12 and the atomic mass of 24. It has 12 protons, 12 neutrons, and 12 neutrons, because you take the atomic mass and subtract the number of protons. It has 12 electrons because it has to match the number of protons. But there are exceptions called isotopes, which is the same element, but it differs in the number of neutrons. So it changes the atomic weight without changing the atom. In magnesium's case, there's 3 stable isotopes: magnesium with an atomic weight of 24, magnesium with an atomic weight of 25, and magnesium with an atomic weight of 26. And here is a shell model of the atom magnesium. In the nucleus, 12 protons and 12 neutrons is present. We know from before that magnesium has 3 shells because it's in the third row, and it's in the second group, so therefore there must be 2 electrons in the outer shell. So if you put that in the model, we will get that there is going to be 2 electrons in the first shell, 8 electrons in the second shell, and 2 electrons in the outer shell. Now we've filled out the model since the number of protons and the number of electrons is equal. The magnesium atomic ion, or just called iron, is magnesium with a charge of 2. The reason that it has a charge of 2 is because it wants to be one of the noble gases, which is in the 8th group. And since magnesium is in the second group, it would like to get rid of 2 electrons to reach the noble gases. Magnesium has a plus iron because getting rid of 2 is easier than gaining 6. So for example, would magnesium very much like to pair with oxygen, which have 2 negative ions, because then they would both become a noble gas, with magnesium losing 2 and oxygen gaining 2. We also have polyatomic ions, which are a group of atoms which is bonded together. Therefore, an example could be magnesium bonded together with sulfur and 4 oxygen atoms to form magnesium sulfate, which has the chemical equation of MgSO and a subscript of 4. This process is called ionic bonding. So now I'm going to show you an experiment of what happens when a magnesium ribbon is heated up. As you can see, a bright white light were produced by the burning of the magnesium. What happens is that the combustion of magnesium in air creates so much energy that a small part of it creates the white ultraviolet lights. If you write this as a balanced chemical equation, it would be 2 magnesium plus 2 oxygen atoms, and it will form 2 MgNO. So we see that the reactants combust with oxygen, which makes a product called magnesium oxide. So what do we use magnesium for? Magnesium is used for super strong lightweight materials, which is also why magnesium was one of the main aerospace construction metals. In the manufacturing area, we use magnesium for many things, such as for example engine parts or a car frame, due to the properties mentioned before. Magnesium has also been used as a strong light source in photography, as you could imagine from the experiment just shown. Magnesium also have a lot to do with our daily life, because it's also used in many household items, such as paper, where magnesium sulfide is used in the manufacturing process, and in foods where magnesium salts are very likely to be present. We also have magnesium a lot in biology part, with for example the plant life. Photosynthesis couldn't happen if it weren't for magnesium. When plants need chlorophyll, which is the chemical that is needed for the plants to take in the sunlight, and chlorophyll is a magnesium-centered porphyrin complex. And in that, as you're going to hear, it's not possible without magnesium. In humans, magnesium also makes the working of many enzymes, which are mainly stored in our bones. So that's my presentation.